Thank you, Axel, for the very gracious introduction. Connecting to the last talk, my name is also really easy to pronounce, so I should get lots of trust from people. So I'm going to talk about a paper that's joined actually with a social psychologist, Bob Kraut, and an information scientist, Rasta Farzan, and two of our graduate students, Iman Yakazari and Ark Chen. So this is going to, you notice the title has changed, and that's because it's a very new paper. The data collection ended at the end of November 2016, sorry. So this is about identity and impact on public goods contribution, and the public goods in this context is Wikipedia. I teach a course at Michigan called User-Generated Content, and it used to be called Public Goods. And it's now changed its name because it's at the School of Information, and also because the examples I used in the course has evolved from, the lamp post, streetlight, national defense to Wikipedia, Kiva, online communities, open source software. So these are becoming increasingly important in terms of what we consume. So you see some Chinese characters because I gave the first talk in China, so that it is quite universal. So we have online reviews, Yelp, Amazon's reviews, and very successful internet encyclopedia, such as the Wikipedia. So we start in economics from the idea of pure public goods, which by definition is non-rivalrous. Your consumption doesn't reduce my consumption, and non-excludable. So in online communities, lots of times, non-excludability is by choice. So the online platform decides not to exclude anyone from consuming the content. So moving from national defense and public schools to public information goods, the non-rivalrous properties still hold, and I just mentioned that it's mostly non-excludable by choice. The other feature is that quality really matters. So this differs fundamentally from, let's say, charitable giving. In charitable giving, my $5 is essentially a perfect substitute for, let's say, Axel's or Bettina's $5. Whereas in content generation, everyone knows something, and that could be something that's very special. That's your expertise. So we're going to basically tackle this problem, which is, often what you see is the free rider problem for public goods provision in a very different production environment. So instead of assuming everyone's inputs are perfect substitutes, that there are complementarity between people's inputs. So this is done on Wikipedia, and it is the top 10 most visited sites in the world, and there are more than 500 million unique visits each month. And it's primarily the active contributors, they're called Wikipedians, are primarily non-experts, they're enthusiasts, which means that their contribution, might not be accurate, especially in science domains. And experts, suppose you have a Ph.D. in psychology or economics, you might be browsing. So if I encounter a new concept in psychology, I might do a search, and the first item typically is a Wikipedia article. And that's my starting point. So I look at the references, and then I dig deeper. In my own field of study, I sometimes also look at the Wikipedia article, but then I see, well, there's sorts of imperfections, and I don't really agree with a particular definition, but I typically think, I'm too busy today. I'll do it another time or let someone else fix it. So there are two big holes in Wikipedia articles. One is science entries, and this is because there are very few domain experts involved in writing science entries. So they're often imprecise and erroneous and incomplete. And so it's so bad that in 2016, the Wikimedia Foundation, which runs Wikipedia, designated the year as the Year of Science. So hoping to attract more attention from scientists and domain experts. The other hole, by the way, is women. Entries related to women, because more than 80% of the Wikipedians are male. And so the most single complete entry or class of entries is military history. So I realized that some of my fonts are too small because the screen is so receded. So I'm just going to read out loud. This is a definition of experimental economics. And it talks about, lab experiments using real incentives and completely ignore field experiments, which is a large growing area. Again, I'm going to skip through this this is instrumental variable. And it says instrumental variable is used to estimate causal relationships when controlled experiments are not, are not feasible. Okay. And we know, as a matter of fact, that in controlled experiments, we often use instrumental variables to control the endogeneity problem. In fact, randomization is one of the gold standards as an instrument. So it's incorrect. And Vickrey auction here says generalized variants of the Vickrey auction for multi-unit auction exist, such as the generalized second prize auction used in Google. Again, it's the incorrect generalization, and it doesn't have the dominant strategy property anymore, so it's simply wrong. And this, for an enthusiast who have taken maybe a couple of courses as an undergrad in economics, it's difficult. But for someone who studies auctions, you can just read it and spot at least, immediately where the mistake is. And this is, again, stress how important it is for experts to get involved. So we're going to look at a very practical question, which is most experts are very busy. How do you motivate them to contribute to public information goods? When people, and I also hear from colleagues, the entry on Pareto efficiency is just not right. It's missing half of the literature, or it's missing this very important survey paper, but the person who spoke this, the statement did not really fix it. So what we're going to try to do is to essentially push two levers. One is broadly defined as public benefit or the impact. So we know from lab experiments that the number of recipients is important in terms of how much people contribute to public goods. And there's also a really neat 2011 AER paper that looks at a natural experiment. So the internet in China has this unfortunate property that it gets shut down, or a certain section of it gets shut down in an unpredictable, truly exogenous fashion. And so that includes blackouts of Chinese Wikipedia. So the good news for econometricians is, since these are exogenous and random, you can identify causality through these blackouts. And so that's exactly what Zhang and Zhu did. So they look at the exogenous reduction in readership in the Chinese Wikipedia and look at people who are not blacked out. So editors and readers from mainland China are shut out when Wikipedia is blocked, but contributors from Taiwan, Hong Kong, and overseas Chinese are not blocked. But even their contributions reduced after the Chinese Wikipedia was blacked out. So, which means that the perceived impact of the Wikipedia articles has an effect on contribution. So we're going to manipulate that part in the experiment. The other part, the other lever, broadly speaking, is private benefits. So for academics in this particular context, we care about citation and we care about, how our work influenced the world. I first call it private, social impact and private impact, and then the name causes more trouble. So I just call it impact. So social image and impact are both important in terms of private benefits. So the literature primarily looked at what motivates Wikipedians to contribute to Wikipedia. So these are insiders. They're already contributing. And they find that better matching, lower cost, reciprocity are all motivations. In this project, we're going to bring people who has never contributed into Wikipedia and ask, what gets them to contribute. Okay. And also, if you have questions at any time, just feel free to ask. So the design consideration is we will both increase the benefit of contribution and then manipulate the cost. So in terms of increasing benefits, we're going to increase the social impact, which is the number of views of a particular Wikipedia article over the past 30 days. We're going to vary that. And we also look at the private impact, and we have 3 different ways of saying that this article is likely to cite your work, might cite your work, might be especially relevant. And there's another private benefit manipulation which didn't work, which is to have a public acknowledgement of your contribution. It turns out that the public acknowledgement, which is Wiki project economics, in this case, is not that well known. Okay. The other way to get people to contribute is to reduce the contribution cost. And we do this in 2 different ways. One is to recommend Wikipedia articles that matches your publication or your working paper. Okay, so this is through a text analysis. And this ex post is a way to also make your identity salient. So if you say, I am a behavioral economist, our email title will say, behavioral economics articles in Wikipedia. So this is self-identified labels that we take from RePEG. The other one is that the matching reduces entry cost. So think about the Vickery auction entry, right? If Axel is asked to take a look at that article, he can see right away that sentence is wrong. So a good matching reduces the cost of commenting and contributing. So what we did, this is the precise experimental design. So we did a 2x3 factorial design. So on one dimension, we vary the social impact, and that's the number of views in the past 30 days. So in one condition, we say that the average, the number of views of a typical or an average Wikipedia article in the past 30 days is 426, which is the real statistics. We actually crawled the views page. The other one is high view, which is the number of views of the recommended articles is at least 1,000. Now, all the articles in our recommendation bank have at least 1,000 views, so they do not differ. But we vary by either telling them that it's the average number of views or the average plus at least 1,000. And so we call has been viewed at least 1,000 times, the high view condition. And then for private impact or private benefit, we either don't mention citation at all, or we say the article might cite your work or might reference your papers, or we say citation and public acknowledgement. So in our pilot, we sampled about 180 economists. So of those who contributed, we put it in the Wiki project economics page, and we'll put a link there, and we say we'll put your name there as well after you contribute. So this is basically how the experiment was designed. So average view, high view, no citation, and citation plus acknowledgement. Okay. So any questions about the experiment design? All right. Yeah.
How did you face the letter? So you sent them a letter?
I sent them an email. So I'll show you the email, what the email looks like. Actually, this is the other part. After we've carried out the experiment, I would go to a party and be introduced to someone, and the person would say, oh, how many more emails are you going to send me? So, yes?
I'm just wondering, do experts take Wikipedia completely serious? I mean, in a way, with your treatment, what is named personally social,
Yeah.
you tell them how many people see the webpage.
Yeah.
This also indirectly tells the people Wikipedia has somehow to be taken serious because so many people see the webpage. It's not only the impact that you potentially have on the society, it also tells you can also update about how important Wikipedia might be in a society.
Right, so we don't know how important a scholar perceives Wikipedia, but the views is an index of how it impacts the general public, right? It might not have written really serious articles in your domain of research, which you can help improve. But when you do Google search, oftentimes the first entry is a Wikipedia article. So it is influential in that sense, that it influences the general public. Okay, so this is how we actually do our experiments. So we do have a plan to actually push it across all academic domains. So the first stop is economics, because we know something about the field. So we retrieve the participant information from REPAC. Do people know? How many people have registered REPAC accounts? 1, okay. 2, maybe 3, okay. So this used to be, before Google Scholar came out, so this used to be the working paper archive for economists, and it was the only one for a while, and then SSRN came out, and the physicist has archive. So this was the equivalence of the archive. So why REPAC? We would have liked to use SSRN, but it does not allow random people to crawl the data. So every website has a data use policy. If you go to the main URL and do /robot, it has the list of variables that you can or cannot crawl. So the data use policy does not prohibit us from crawl the email address and other information. And especially important is that when people register at REPAC, they put down their field of expertise. So I would put down, behavior economics, experimental economics, mechanism design. So these, if you will, is a precise label. So we don't have to use computer algorithms to infer the label. And it's part of your identity, okay? This is the work I've been doing all these years. And, you will see that it gives you a ranking. The ranking is not publicized. The algorithm is not publicized, but it roughly has to do with the number of downloads, views, and citations. And so it gives you once a month, the person who runs REPAC sends you an email saying that, your ranking is in the top X percentile. And so as an individual, you would know exactly what percentile you're in. In terms of impact factor, from the outsider perspective, it's binary. We only know whether someone is in the top 10% or not. Okay. So this gives us a way to look at reputation, and it has a paper archive, working paper or published paper archive, which is used for us for matching. And so how do we select the experts? So there are about 10,000 economists who have posted at least one paper on REPAC in English. And since the experiment was going to be run on the English Wikipedia, we thought, we're going to use publication of the English article as a benchmark. But we use the criteria of someone who has at least 6 articles in the working paper archive. And the reason for that is because our matching is done by an algorithm. It's not by hand. And so the algorithm could get it wrong or right, and we're hoping that out of 6, at least one of the recommendations is correct. So this is just as if when you buy a book on Amazon, it will tell you, customers who bought, The Beautiful Mind also bought the Turing Machine and Osborne Rubinstein's game theory. So it would typically give you 4 to 5 recommendations, and hopefully one of them is the right recommendation. So that's the same idea. It's because our algorithm is not perfect. So our sample size is about 4,000, okay? So the experiment has 3 phases. In the first phase, we send a personalized email invitation to the experts, So that's when we implement the treatment. I'll show you what the email reads, what the email is like. And the second phase, if you click yes, then we will recommend relevant articles to the expert. And that's each recommendation matches to one of the expert's articles. If you post more than 6, would take the most recent 6 articles. And then after your contribution in the third phase, we send a thank you email, and we give you links to where we post your recommendations, which is on the respective Wikipedia's talk page. And then we also give you a link to a tutorial on how to edit Wikipedia articles in case you want to do more. And only 3 people click the tutorial page. So this is the phase 1 email. I realize you probably you cannot read anything. So I'm going to read it. Okay, so this says, Dear Dr. So-and-so, would you be willing to spend 10 to 20 minutes providing feedback on a few Wikipedia articles related to behavior and experimental economics? This is your self-identified field on RePEG. And we say Wikipedia is among the most important information sources the general public uses to find out about a wide range of topics. That's the general blurb in every email. And we say a Wikipedia article is viewed on average 426 times each month, which is true, which anchors your belief. And we say while many Wikipedia articles are useful, articles written by enthusiasts rather than experts can be inaccurate, incomplete, or out of date. The next paragraph implements the treatment. Okay. So if you're willing to help, we'll send you links to a few Wikipedia articles in your field, in your area of expertise. We'll select only articles with over 1,000 views. So this is the high view condition, okay, in the past month, so that your feedback will benefit many Wikipedia readers. And then the next sentence says, these articles may include some of your publications in their references. So this is the citation benefit. And we randomize the order of these 2 factors when they're both included. And then we say, please click one of the following links to continue. So yes or no. And we signed our real, so Bob and I signed our real names. Okay, so that's how the treatment was implemented. Yes?
I have one question. In case they give feedback on the articles, is their name mentioned in the article?
It's mentioned on the talk page. So each Wikipedia article, when you open it, it will tell you immediately, it goes to the article page. But there are several tabs which usually nobody click on it. One is history, which gives you the complete history of edits. The other one is talk. So the talk page is where the Wikipedia article writers coordinate their work. So if I suppose I'm in the public goods article, and if I say, well, the Samuelson condition should be put in, the 3rd paragraph, and then someone else says, well, that's too specialized, I don't agree. So where do you see these discussions? It's on the talk page. So we post your comment on the talk page. Okay.
So I ask because, as we know that there are many articles that are not that good, whether there might be a lot of people or a lot of experts that do not want to be directly connected to articles.
Right.
It's rather a bad sign than a good sign.
Right. That's a legitimate concern. But your name is never on the Wikipedia article as a writer. So the only way you find out who the writers are from the history page and the talk page. And most of the times they actually use pseudonyms. They don't use their real name. Yeah. Okay, so this is the response. If you click yes, we say we're happy that you're interested, and we just send you an email including the recommended articles. Again, this is the feedback is instantaneous. If you say no, we say we're sorry that you're not able to contribute at the moment. You can always contact us or click the yes. In fact, that's only true till the end of December. So once you say yes, the phase 2 email says thank you for your willingness, and then gives you the articles, 6 articles here, each matching to one of your publications. And if you want to review, you can just click. That will take you actually not to Wikipedia, but to our server. This is the actual number of views of that article in the 24 hours before you receive this email. So all the information would dynamically updated. Okay. So this is someone who's in the high view condition. Okay, so they're showing the actual views. And so what happens if you click the link? It's a little bit cut off. So instead of teaching you how to edit Wikipedia articles, this is one of the design features that lowers the cost of entry. Okay, so this is our server. So on the right-hand side, you see the Wikipedia article on microeconomics. On the left-hand side, it's all text boxes. So you're asked to rate the quality of the article, and you're asked to write comments. This is the feedback box. So as long as you know how to type, you can make your comments. You don't have to know how to edit the wiki, okay? And if you want to recommend other people, so sometimes our colleagues recommend their graduate students or their other colleagues, they put it in here. And once they submit their entries, let me see. It's a bot actually posted on the Wikipedia talk page. Okay, so this is to make it very, very easy to edit. So the emails are always sent during the day of the local time. And if you click yes, phase 2 email gets sent right away. If you click no, you're dropped right away. Okay, so we're not contacting you anymore. If you don't respond, you just let your email sit in your inbox. Then we send 4 reminders, okay, in 2-week intervals, and that could be annoying. That's why I get bugged at parties. Okay, so the other part is the comments are manually verified before we post it on the Wikipedia talk page. So we make sure that the content is actually good, meaning relevant. And so how are they posted? So this field experiment actually involves a lot of behind-the-scenes stuff. One of them is to get the bot approved by the community. So we developed a bot, it's called the Expert Ideas Bot. So it posts the comments on the Wikipedia article talk page, not on the article itself, and alert the Wikipedia editors who watch this page that something has been posted. And so we were hoping for the best case scenario, which is a division of labor. The experts has expertise on the content, and therefore they edit the content. The Wikipedia editors knows how to edit and knows the culture of Wikipedia. So they know what stays and what gets reverted, so they do the incorporation. So in the best case scenario, editors will incorporate these comments. In the intermediate case, the editors comment on the comments, but don't incorporate them. And the worst case scenario is nothing happens. Okay, so guess what happened? Nothing happens. The worst case scenario. So it depends on the field. So econometrics and statistics are the comments are almost all incorporated because that's the most active group on Wikipedia. The statisticians and mathematicians. So lots of them are incorporated, and for the others, it's the worst case scenario. So more than 90% of the comments are basically just sits there. Okay. So what I've been exploring is to get my game theory, make it a homework assignment, which is actually a very meaningful homework assignment for my undergrads. Usually if they do, for game theory, for example, which I just taught in the fall semester, usually they finish homework assignments and they're done. They take the exam, they're done. They don't have any impact on society. And here I say, here are some articles related to game theory, such as coordination games, prisoner's dilemma, mechanism design. You've learned something. So adopt an article, take one, and here are the experts' comment, evaluate it and incorporate them. And so my students incorporated a bunch of comments into the article. So that happened in mid-December. That's one of my assignments. And I asked my TA to check, 4 months later, 100% of the incorporated comments stayed. Nothing gets reverted. And that's actually, in Wikipedia, if you're familiar with the Wikipedia culture, that was incredible, okay? Especially for new editors. So here are hypotheses, okay? So any questions about how the experiment was designed or implemented? So notice that the treatments were all implemented in the first phase. Once you move beyond the first phase, there will be selection bias. Okay, so the treatment effect is all on the interest, which is yes, when they say that yes, they're interested. So the first one says domain experts will be more interested in contributing when citation benefit is made salient. So that's if you write down a standard public goods model, that's when you increase the private benefits to the public goods, it would increase contribution. The second one says that they'll be more interested in contributing when article social impact is made salient. So that's from the empirical results from the Chinese Wikipedia and Jim Andreoni's previous work. And the third one says they'll be more interested in contributing when both factors are salient, and in particular, that should dominate, the effect should dominate the previous two. Okay.
One question on the
yeah.
first. As I recall correctly, in your email you wrote your article has been cited already.
No, so we say it might cite your work, or it might reference your papers. We say it might. For some people, for instance, Guido Imbens was recommended instrumental variables and regression discontinuity design. And his article was already there, okay? And same is true for Josh Enquist and so on. So you expect, the anticipated people are already in. And so, so basically what I'm trying to say is that there is no deception on our part. And so this is randomization check. On the article. So if you look at the average view for, number of characters, so article length, views, cosine similarity, and the categories. So Wikipedia has 6 quality categories for each article. So the bottom line is they're fairly balanced, ex post. So we randomize the articles into these the experts and articles into these treatments, and they're fairly balanced. This is randomization on the experts level for each of the experimental conditions. Again, I apologize, this is probably too small for this distance. So they are, again, fairly balanced. And I want to point out one variable, which is called related field, and that's behavior and experimental economics and game theory. And that's because I use my real name in sending out the emails. And what's good is it's only about 5% of the experts are in each of the experimental conditions, so they don't dominate. You see that they respond slightly differently. Also, the other thing I want to call to your attention is that people who are rated as the top 10% of the experts, of the economists, on RePEG are about 25-26% of our sample. And that's because we have the 6 article cutoff. Okay, you have to have published at least 6 papers, and that cut off probably younger researchers or more junior researchers. So for the outcome variables, in phase 1, we're just going to look at how many people click yes. And then for phase 2, we're going to look at contribution quantity in terms of character counts, and also contribution quality. That I'm not able to present today because the coding is still ongoing. Okay. So let's take a look at phase 1. This is the treatment effect on interest. And so this is the proportion of people in each experimental condition who are interested, who click yes. One thing that strikes you is that it's very high, okay? So the response rate overall in every cell is about 44%. And the reason it is striking is because my colleagues Bob Kraut and Roster Farzan did a field experiment among psychologists, and they did not do this matching, sort of matching expertise. So they sent out an email basically telling the psychologists in the name of the American Psychological Association, saying that, Wikipedia article is really important, so all of our stuff in front, that you should contribute. You're the experts. And their response rate was lower than 1%. So low that they did not have an article, and I can't even reference that, but I'm going to tell you why it was striking, that we got 44%. The other part is that the citation, basically here's a likelihood of citation, and here's likelihoods of citation, plus we're going to post your article, your comments, your name on the Wiki Project Economics page, which is public acknowledgement. The public acknowledgement didn't do much at all. So they're not significantly different if you go this direction. So as a result, we're going to just reduce it to a 2x2 design in our analysis, because the last two columns both mention likelihood of citation. And so what you see here is, if you just talk about the average view and do not mention citation benefit, it's about 45%. And if you mention citation benefit, it goes up to 48%. And that is significant. The other part is when you say it's high view and then mention citation benefit, it reaches 50%, 50.4%. And that, again, is significant at the 5% level. And the controlling for whether you talk about citation benefit or not, the average view, when you bring it to high view, has no effect. Okay, so in one dimension, which is the social impact by itself has no effect. So the first result says, under both the average view and high view, citation benefit significantly increases interest. So what's pushing the sort of roughly 5 percentage point increase of interest is all private benefit, if you will. Yes?
What is the sample size?
The sample size, so we have 4,000 altogether, and 85% of them actually opened their email. So the sample size is about 700 to 800 in each cell. Yeah. Any other questions? I mean, these are very conservative tests. Okay, these are non-parametric tests, Wilcox and Ransom. Okay. Okay, and so for this phase, we added some covariates, and the reason is my student Iman thinks that it's important to look at how behavior and experimental economists behaved. And they do behave differently. They're more like 20 percentage point more likely to say yes. They're 13 percentage point less likely to say no, and they're also less likely to not respond at all. But they're only about 5% of the sample. Okay. And then the second phase, we look at the length of comments. Okay. So these are the character counts in each of the experimental conditions. The one thing to realize is there's a huge variance in the length of comments. We have people who rewrote the entire article, and we also have one-sentence comments. The one-sentence comments are not necessarily bad. For instance, we have an expert in coordination experiments. He looked at the coordination games entry, and he wrote one sentence. He said, some are good, in parentheses, theory, some are bad, some are not so good, in parentheses, experiments. And then he gave us a survey article on coordination games in experimental, which is all we need. So short is not necessarily bad. And so here's an idea of what the experts did. Okay, so this is the entry on the traveler's dilemma. So the original one says, when the game is played experimentally, most participants select a value close to $100. Excuse me. So traveler's dilemma is where it's in the 10 Little Treasures article by Holt and Horay. It's one of these games that gets economists to re-examine the idea of Nash equilibrium. And the expert says when the game is played experimentally, most participants select a value. Now the red is what he added, higher than the Nash equilibrium and closer to $100. More precisely, the Nash equilibrium strategy solution proved to be a bad predictor of people's behavior in a traveler's dilemma with small bonus malus, and a rather good predictor if the bonus malus parameter was big. Okay. So the expert's summary is much, much more precise and comprehensive because he considered both cases, when the parameters are high and when they're low, and when Nash equilibrium is a good prediction. And so who's the expert in this case? Is Pier Giuseppe Moroni, who the reason we recommended the article was because he published this paper, which is Individual and Group Behavior in the Traveler's Dilemma, an experimental study. Okay, so he has basically dig through the entire literature. So for him, making a comment to improve the article is low cost, and he has the expertise to do so. Okay. Yeah.
But in a way, he also made it maybe more precise, but he also made it more complicated to read for the readers.
Yeah.
So it could be that people don't read the article anymore because they just see it's too complicated.
So that, I have no idea. So I don't know what people use Wikipedia article for. Some probably as an entry point to go through the articles, but my intuition is that the more precise it is, well, first of all, it should not be wrong, okay? Yeah. Second, one can argue that the original summary was partial and therefore not correct. You know, so whether people would stop because it's too comprehensive, I don't know. So I don't know the answer to that.
You can even test an experiment, but
Yeah. So my strategy is if there are sections which are very technical, let's say in behavioral endocrinology, I would skip sections which are too technical, but just take the information that I was looking for. Okay. So this is the regression result on the length of comment. So if you will, this is the phase 2. The phase 2 result, how much people contribute. And after people click yes, a third of the people who click yes actually contributed. So, which is why we use the zero inflated negative binomial to account for the 2/3 of zero contributions. I want to say two things. One is some people didn't contribute, or they write an email saying, I'll do it at the end of December, and they never did. It's like we're overloaded with referee reports. So overcommitment might be one reason. The other reason is some of our recommendations are not so good. Okay. So, for instance, Guido Imbens wrote back and said, of the 6 articles that you recommended, 4 of them are good, 2 of them are not precise. So I'm only going to do 4. So these are the 2 reasons. So if you look at this robust result, whether you use zero inflated Poisson or zero inflated negative binomial, we went through all sorts of specifications. And cosine similarity is always the most robust predictor. So cosine similarity is what computer scientists use to measure the similarity of articles, of two papers or 2 articles. So what you see here is the odds ratio. What it does is essentially looking at, suppose you have the expert's abstract, that's what we take from the expert's article, and then we take all the non-trivial words, drop the or a, and take all the substantive word and make one vector out of it. So let's say this is vector A. The second document is the Wikipedia article. Again, we take all the important words, we make another vector. And so the entries of this 2-dimensional matrix are all 0 ones. Every time they have an overlapping vocabulary, we put a 1 there. If they don't, then we put a 0 there. So cosine similarity is essentially the normalized dot product between these two vectors. And it's in natural language processing, it's a way to say how similar 2 documents are. Okay. So what does that mean? If the more similar your abstract is from the Wikipedia article, the more you contribute. it's lower entry costs and is a good match, essentially, to your expertise. So this is, if you look at the zero inflated negative binomial, the citation in the second stage is not significant anymore. If you do cross-random effects linear mix models, where you have basically random effects on the expert and on the article, you have very similar results, which is cosine similarity is highly significant in predicting behavior. So, so this is a summary, which is in phase 2. The more relevant the article is to the expert's paper, the longer is the comment. And there's no significant effect of citation by itself, but high view, the number of views, the high view condition gets more comments. So this is using each comment as an independent observation. If we want to be very conservative, so let me go to, okay, so I think I've said this. The more relevant is the article, the longer is the comment. But if you look at the a really conservative measure, which is, suppose the experts make comments on 3 articles, but they're all from the same expert. So a really conservative measure is to take each expert as an independent observation. So we add up the comments from all 3 articles and use that as the experts or total contribution. So we basically reduce our number of observations to 1604. In that case, cosine similarity still survives as an important predictor of quality. And the other interesting feature is people who are in the top 10%, rated by REPAC. So these are probably the more senior, more influential people are less likely to, they contribute less or fewer characters. That's what it means. So these are the incidence rate ratios, which means that if it's below 1, that means it's less. Okay, so I'm going to conclude. So when we elicit interest from the experts, we show that the likelihood of citation has a significant effect, and social impact, which is the high view condition, by itself does not have an effect. But social impact has, combined with citation, has the highest, at least, point of interest, which reaches 50%. So that's why the original title is called the social impact multiplier. You have to multiply it with the private interest or the private impact. Once we go beyond the first stage, in terms of effort, the relevance of an article can encourage contribution from the experts. And articles with higher number of views also receive more contributions from the experts. So at that point, when you're in the second stage, what you're trying to trade off is, of these 6 articles, which one I should be commenting on? And you see the real views, the actual views of the articles. So social impact at that point has an effect, and also what's really robust across multiple specifications is the cosine similarity, which is how similar the recommended article is to your actual publication, the abstract of your publication. Okay. So the last part is thinking about going back to theory. So what motivates domain experts to contribute expertise? So this is rethinking about the public goods problem, but not thinking it from the perspective of monetary contributions, but when everyone's unique in some way. So identity is, seems to be an important lever. So one can interpret the close match both as an enhancement of identity and as a reduction of cost of contributions. And one neat part about running experiments on your colleagues is that you actually get to see them afterwards and you can talk to them about why did you contribute to a particular article. So David Cooper came to give a talk at Michigan and he said, oh, I think I was in your experiment. So one of my ARC talked to him about this experiment. He said, I was in one of the conditions, let me see which one I'm in. And then he said the reason he contributed to coordination games is because he's worked on it for many years and that defines part of his research agenda, right? That's partly what he is. He cares about, in his original words, he cares about the fact that this article should get it right. And he also thinks that it's really easy for him to contribute to that article. So both the cost effect and the identity factor seemed important. We can, if I really want to bug people, annoy people, I'll send out another email saying, tell us why you contribute. But we can infer quite a bit just from the data analysis. So we think both the identity and impact are important. So impact here includes both private impact, that's through citations, and public impact through article views. And the reason we're not taking a stand in the title of the paper is people quibble about whether a citation is purely a private impact. It could also be a public impact. So this also ties into the social psychology literature on social loafing. So there's an early meta-study by Carew and Williams in '93 where they look at, I think, 78 experiments in social psychology about how to get people to loaf. Social loafing is the psychologist's equivalent for free riding. And one of the factors that was identified was uniqueness of contributions. So tell people that you are unique. And so in this type of, contribution of expertise, if you tell people or you make people feel that they are unique, increases contributions. So when we present this among computer scientists, one thing that surprised everyone was the fact that 85% of the emails were opened. Okay. The reason we know that was because we put a pixel in every email. So when someone opens the email, the pixel has to load the image from the server so the server knows the email is opened. In online experiments through emails, at most you get a third of the emails opened. Most of them are ignored. And so we think, here this is without treatment or control, the reason people opened the emails was because we put their field of specialty or their identity, if you will, in the title. We say Wikipedia articles in social psychology or in social cognition or in experimental economics. So emphasizing people's uniqueness, that everyone has something to contribute, and you're not perfect substitutes, gets people to contribute content. So that's the sort of, if you will, feedback to theory. I think that's it. That's all the study. And next time I'll tell you about the quality. Thank you. Yes.
Do you think it mattered a lot that you wrote the email or that you signed the email?
It might. So one of the results is the relevant field results. So 5% of the 4,000 economists were experimental behavioral economists, and they are more likely to say yes and less likely to say no or ignore the email. And so I don't know. I mean, my personal experience is the experimental community are also just more pro-social, period. in my first 6 years as an experimentalist, I didn't have a lab. So I was borrowing people's lab across the world. Nobody ever said no. And and that resonates with lots of junior people's experience. So I don't know for sure. The reason Bob and I signed our names was because we thought this is asking, really busy people to do work, to do extra work. And if there are bad ramifications or people complain, they should know who to complain to. But it might have an effect. I just don't. It's a perfect confound in this case. Yes?
I really like this project because no matter what the result would have been, you would have improved everything. You would have improved Wikipedia simply because people better the articles on Wikipedia. So I was wondering, your treatments, if you go back to the public goods games, these are not the strongest effects you find how to increase contributions in public goods games. And there's also research, for example, if you give people the standards of comparison, so others contributed so much to this public good, has very strong effects in these games. So it also might be an interesting treatment to just give people a reference point. Other people in your profession did so and so much on Wikipedia that might even have a stronger effect to
yes, I think so. The effects are not huge, partly because compared to lab experiments, of course, it's sort of not quite comparable. But I think providing role models and social comparison probably would work very well in this area, especially because we do have some very high-profile contributors. I think for econometricians, we can just point to Guido Imbens and Josh Enquist and say, here are 2 examples of your colleagues contributing, and we have a lot in experimental economics and so on, and in theory. I think that would work extremely well. Haven't tried, But really good idea. And I also want to, there's a forthcoming paper in management science by Jana Gallus, who's at UCLA. So she did something really interesting on the German language Wikipedia by randomly assigning awards, sort of like a Bonstar type. You are basically there's I think she called it the Edelweiss award. So basically, it just posts a pretty picture on your page, on your Wikipedia editor page, and people are extremely responsive to this type of awards. So lots of the stuff that we learned from offline settings, I think, can be readily applied to online settings. Yes.
Especially the cosine similarity measure, very interesting. Have you been thinking about going forward with that? Because I can think of a bot just really checking publication abstracts and matching it with Wikipedia entries, and then really automatically suggest, based on the most recent published papers, there's a Wikipedia entry that relates to what you just published. Would you like to comment on it, or maybe even edit it?
Right.
Would that
So,
be a possibility? I'm not an expert on computers, but you're at the School of Information. Maybe.
Right. So since we have a lot of graduate students here, I really highly encourage you to all take a machine learning class. I think it's going to be part of econometrics in probably 5 to 10 years. So what we're good at training in econometrics is to crunch numbers and to sort of figure out causality from the observational experimental data. What computer scientists are really good at is natural language analysis. And so cosine similarity is a standard measure of in natural language processing for comparison, similarity of documents. And lots of these, and so to get back to Christian's comment, this is scalable in the sense that almost all of the stuff behind are automated. So recommending articles, finding similarities are all done by algorithms. The posting of the comments to Wikipedia talk pages are all done by bots. I mean, the difficult part is to get through the committee process in the Wikimedia Foundation, but it's all automated. So I think we can carry it out to other fields and just use algorithms to figure out, what people will be good at. Yes, Axel.
So you mentioned that you don't have yet data on the quality of contributions, but you have data on the quality of the articles. So does this affect contributions? When you see that there are big mistakes in the article?
I see.
People are more willing to get into it, or maybe less willing to get into it?
That's a really good question. Did we check the quality of the article? We did. So this FAGA class is featured article, good article class. That's the two highest categories. And what you see here in the zero inflated Poisson, it increases contributions. But this effect disappears if we go to the much more conservative measure of basically adding up the experts' comments. The importance is also significant. So Wikipedia also has an automated way of assigning importance categories to the Wikipedia article. So what you see is the importance seems to work well. This is incomplete. We should have all 6 classes in the database, and we'll have that information once we're finished with the quality, coding the quality of the comments. Yes.
I'm a heavy Wikipedia user, and I was shocked now to hear, right, that the quality of Wikipedia articles is still lacking. I mean, I would have expected this 10 years ago, then there was an argument, but still, obviously, there's an issue with the content. This very idea of Wikipedia is the wisdom of the crowd. In the end, the truth will prevail, right? When many people work on it. And I wonder what you think about ambivalent topics and political topics. I was always, topics where there's a mainstream truth, but there are parties with high power, a lot of money, and many lawyers who oppose the truth, right? Articles on Scientology, homeopathy, psychoanalysis, and so on and so forth. I was impressed, personally, this is only anecdotal, I was always impressed that these articles feature the truth, right? So, Marlboro cannot suppress on Wikipedia all the smoking, cancer relationship studies, right? Or Scientology is not able, although there are many more lawyers than you all together, they are not able to suppress the truth about their identity, right? I mean, I also know the issue, with the sock puppets, right? Letting people work fully. What do you think about this? Is there a higher chance that truth emerges for these political and ambivalent social, societal topics instead of scientific content?
Right, so the question is whether advertising or biased views, what happens when they get into Wikipedia. Wikipedia has an internal administrative structure. So the administrator is above the editor. Kind of often, if it becomes, it will reversion becomes too excessive. So they have a rule of thumb, and they have a hierarchy of editors, which prevents, for instance, George W. Bush once was a very controversial article, and it was blocked. So ordinary people cannot just go and edit. And any edit has to go through Trump, as you expected, is also blocked. The most controversial article in Wikipedia, actually, you will never guess what it is. Chocolate. So that's also locked. And so controversial topics tend to be locked. And in the age of fake news or alternative truth, Ginny Wells, who was the founder of Wikipedia, just announced that they're going to have essentially a crowd-contributed news site to counter Google and Twitter. So it is to be launched. I think in the next 6 months, we'll see how that goes.
Okay, thank you very much.
Yeah, thank you very much for